people, it is time for day 2, or section 2, of the AP Calculus test review. Lots and lots of derivatives. So let's get started. The first one is if y equals x squared e to the x, then dy dx is equal to what? Well, two things being multiplied, product rule. So first unchanged times derivative of the second plus second unchanged times derivative of the first. What you want to do is you want to match up which multiple choice answer that mostly resembles. In order to do that, you want to rearrange some terms here. So you've got an x squared e to the x times 2x e to the x. From there you can factor out an x e to the x, leaving you with an x plus 2 on the inside, making your answer C. I'll probably move through most of these pretty fast, so some of them are pretty simple and straightforward. So let's go ahead and take a look at the next one. Y equals the natural log of x over x, and again they want us to find dy dx. So that's dx, dy over dx. Well, we got a little bit of quotient rule in our life here, so we've got low d high minus high d low. Derivative of the low is just 1, so I won't even include it, all over x squared. Well, goodbye to you guys. Really, you just have 1 minus ln of x over x squared, and that looks to me like d. Alright, let's do more. Lots and lots more. There are many derivatives. Alright, y equals 2 cosine of, they say x over 2, I'm going to call it 1/2 x. It makes it a little more clear on what rule you're going to have to use. So it looks like dy dx is going to be, I'll go and call it y prime just for variety's sake. It's going to be 2 times the derivative of cosine is negative sine of 1/2 x, and don't forget that the 1/2 needs to chain rule out. Goodbye to you guys. In the past we haven't had you simplify, but now we're going to have you start simplifying things because it's going to allow us to find our multiple choice answers more quickly. So what we've got as y prime is negative sine of 1/2 x. Now they're asking us to find y double prime. So I got to derive this thing one more time. The derivative of negative sine is negative cosine of 1/2 x, and don't forget about a little bit of chain rule by your side. So what you ultimately get is negative 1/2 cosine 1/2 x. In other words, your answer is E. With number 4, I'm going to have to notice a couple things. First thing I want to notice is that there are moving parts in the base and in the exponent, which means I'm probably going to want to use some logarithmic differentiation, which means I'm going to set this thing equal to y. My function is y equals x to the ln of x. And I'm going to go and take the natural logs of both sides. So what I'm going to do is I'm going to say that the natural log of y is equal to, I'm going to get the natural log of x times the natural log of x, or in other words I could say the natural log of x squared, or the natural log of x quantity squared. And that's equal to the natural log of y. So if I take the derivatives of both sides, I'm going to get 1 over y. Don't forget about implicit differentiation. Dy dx is going to equal 2 times the natural log of x times 1 over x. And now all I have to do is just kick the y over by multiplying it. So what I get here, if I separate this all out, I'm going to get dy dx is going to equal 2 times the natural log of x times 1 over x. I can go ahead and just do that. And that's going to be multiplied by y. But remember, the whole time, y was equal to x raised to the natural log of x, and that just so happens to be C. Many more. We are only a fifth of the way there. Actually, that's not even true. Okay, so, more stuff. They want us to derive the natural log of e to the 2x. Now, before you do any kind of chain rule or anything like that, remember, the natural log, well, you can use your exponent rules here to say that this expression really is 2x times the natural log of e. Natural log of e is 1, so goodbye to you. So really, you're just deriving d over dx of 2x. 2 is your answer. In other words, e. 6. F of x equals x plus sine x. Super straightforward. F prime is equal to 1 plus cos x. The answer, whoops, is A. 7. F of x is equal to x minus 1 over x plus 1. There is no way around this one. You have to use a little bit of quotient rule by your side. So, low, d high, derivative of the high is 1, minus high, d low, derivative of the low is 1. Square the bottom, and away we go. Cool, so now we are going to simplify this thing a little bit. This is really x plus 1 minus x plus 1. So really, I get 2 over x plus 1 quantity squared. Now, they want us to evaluate the slope at x equals 1. So I'm going to go and plug a 1 into there. So I get a 1 plus 1 quantity squared. That is 2 on the bottom, squared is 4. 2 over 4 is 1 half, which equals D. 5, 6, and 7 were pretty straightforward. Let's do more. Okay, now, if you look at the way number 8 is written, I'm going to go ahead and write it in a different way. I'm going to say y equals, instead of cos squared 3x, if you remember, I used to have you guys write it like this. That way you had a better idea of what was actually being derived. Really, what you have when you take the derivative of this thing is you're going to get 2 cos 3x times, the next inner function is not 3x, it's actually sine 3x. And just kidding, that's negative sine, because the derivative of cosine is negative sine. I almost lost it there, but I caught myself. And now the 3 comes out. So really what you have is negative, not that kind of line, negative 6 cos 3x sine 3x. In other words, the answer is A. 9. Y equals 3 over 4 plus x squared. Now, before you bust out quotient rule on this thing, because there's just this single constant term up top, this one would actually not be a bad idea to raise the whole shebang on the bottom to the negative 1 power. Because now y prime, which is what I think the only thing you're finding, y prime really is just going to be negative 3 times 4 plus x, I'm running out of board space there, x squared to the negative 2 times 2x. Remember, chain rule of this thing. So that's going to be negative 6x over 4 plus x squared, quantity squared, and that right there equals A. Number 10. Oh, wow. A reverse derivative, otherwise known as an antiderivative, otherwise known as an integral. So, first thing you want to think about, is what derives into cosine. Well, what derives into cosine? Well, that's sine. And don't forget about the 2x right here. Now, what you need to see, without getting into the heavy u sub stuff, is if you notice, if you had to derive sine 2x, you would have needed something to cancel out the 2 that would have chained out. So you throw a 1/2 there, because the 1/2 will cancel out the 2, and don't even think about forgetting plus c. And there you have it. That's 10. We're almost a third of the way there. 11. Y equals 10 to the x squared minus 1. Okay. Whenever you have a base that's being raised to an exponent that has a variable in it, and you have to take the derivative, remember, it behaves a lot like e to the x. It really is just itself. And don't forget about the 2x that's going to chain out. And then don't forget it's going to be multiplied by the natural log of the base. And now you just have to find out which answer best matches what you have right here. That answer is D. I believe they have it as 2x times 10 to the x squared minus 1, and then they throw the ln of 10 on the... So they just switched. They switched the 10 and the 2x. That's all they did. Cool. Moving on. Ooh, excellent problem. Now, before you get too far ahead of yourselves and start doing all kinds of crazy chain rule and all these things, it would help if you would face south, put your tongue on the roof of your mouth, and do some Qigong meditation for a little bit, because this is an identity. This is double angle of cosine, which means y prime is a piece of cake. It is negative sine 2x times 2, and then you figure out which one best matches that. That is C. Ooh. Y equals tan inverse of cos x. Well. Oh, wow. Party next door. Cool. Anyway, let's see here. The derivative of tan inverse is going to be 1 over 1 plus the thing, in this case, the thing being cosine x squared. And don't forget, you have to derive the inner thing. So throw the negative sine x out there, and if you want to simplify, go for it. From here, I just realized that the answer was A. Cool, moving on. 14. Okay, if you look at 14, I'm actually going to go ahead and write 14 in a way that will allow me to derive this thing faster. Remember, you're trying to get through these questions as fast as you can. Because on the AP test, you have a timer. You are fighting the clock. So you want to manipulate these things as fast as you can. Alright, so we're going to just derive this thing, and I think we're going to find out the derivative at x equals 1. So negative 3x to the negative 4 plus x to the negative 2 plus 2x. And now I want that for when x equals negative 1. Sorry, not 1. Throw negative 1s all the way across. So negative 3 times negative 1 to the negative 4 plus negative 1 to the negative 2 plus 2 times negative 1. These are even, so they're not going to impact anything. It's just really 3 plus 1 minus 2, which is going to be negative 4. And that answer just so happens to be B. Moving on. Oh, wow. It really is that simple. F of x equals x to the 3/2. Okay, not hard, but it's always on the easy ones that we make a mistake, so be careful. 3 over 2 x to the 1/2. And I believe they want us to find this at x equals 4. So 3 over 2 times 4 to the 1/2. Well, the square root of 4 is 2. Those are going to cancel each other out. You get 3. Which just so happens to be C. Alright, that's through 15. We're almost halfway there. Let's keep moving. 16. We haven't seen this in a long time. X cubed plus 3xy plus 2y cubed equals 17. When you see x's and y's all mangled together, the first thing you should think about is implicit differentiation. So it looks like we are going to get a 3x squared plus 3 on the outside, product rule here, first times derivative of the second plus second times derivative of the first plus 6y dy dx equals the derivative of 17 is 0. Okay. Now, we get all the dy dx's by themselves, but check this out. 3 on term 1, 3 on term 2, 6 on term 3. Kill off the 3's. You get x squared plus x dy dx plus y plus 2y dy dx equals 0. Get all the dy dx's by themselves, so that means I'm going to get a negative x squared minus 2y. I moved, just kidding, not minus 2y, it's minus regular old y, minus y. I have moved this thing over, and I have moved this thing over. And that's going to equal dy dx times x plus 2y. I have now factored out this thing, goodbye to you, and factored out this thing, leaving me with the x plus 2y on the inside. Kick this thing over. I get dy dx is equal to negative x squared minus y over x plus 2y. Now, you have to look for which version of this actually matches. What they have is negative in the middle, x squared plus y over x plus 2y. Now, if you just distribute the negative in, you'll get back to where we were. That answer just so happens to be A. Wow, that one actually took quite a bit of space. So, let's keep moving. Y equals tan x minus, oops, don't forget about that x, minus cotangent x. No way around it, you just got to do it. This is going to be secant squared x. This is going to be negative cosecant squared x, which is plus cosecant squared x. And that really is all there is to it. E, whoosh, dead. Good job. Ooh. F of x equals x squared, just kidding, not x squared, x minus 1 squared. With a sine x on the outside. A little bit of product rule in our life, and I think we're going to try and find the derivative at x equals 0. So derivative, generally, is going to be the first unchanged times the derivative of the second, plus the second unchanged times the derivative of the first. Now, a 1 technically chains out, but we don't care about him. Now, if I want to find f prime at 0, I just start plugging zeros in. So that's going to give me a negative 1 squared in here with a cos of 0 plus sine of 0 times 2 times negative 1. But you know what sine of 0 is? Goodbye is what sine of 0 is. So all I have is a 1 times 1, which is 1. The answer is 1, which means the answer is D. Cool. 19. The integral. Okay, cool. The integral of 3x squared over rad x cubed plus 1 dx. Okay, reverse chain rule this thing. U sub. U is going to be x cubed plus 1. Du is going to be 3x squared dx. Notice, you have a 3x squared dx right here. That's going to give you a 1 du up top. No remainders, no nothing. You're going to get 1 over rad u du, and you're going to integrate that, which is the same thing as the integral of u to the negative 1 half du. Now, when you integrate this thing, you're going to get a u to the 1 half times 2, because it's really divided by 1 half, plus c. Now, all you have to do is figure out what c, what u is, but that's not that hard because it's really just this thing, x cubed plus 1, and then plus c on the outside. That will lead you to the answer of A. Next one. Ooh, more stuff. More chain ruling stuff. Chain ruling type stuff. X squared minus 2x minus 1. The bait is to try to factor that thing and do something with it. Don't fall for it. F prime is 2/3 x squared minus 2x minus 1 to the negative 1/3 times 2x minus 2. And don't forget about those parentheses there. Cool. So now we can go and just plug stuff in if we really, really wanted to. We're trying to find f prime at 0. That's going to be 2 over 3 times 0 minus 0 minus 1 to the 1/3 times 2 times 0 minus 2. Okay, look, I have to scroll down on this one. Okay. So that's going to be, the negative is going to live because we're taking it to the 1/3 power, so it's going to be negative 2/3 times, this looks like negative 4 right here. Oh, just kidding, sorry, what am I saying? Not negative 4, negative 2. Got a little ahead of myself. The answer really is just positive 4/3. Let's keep moving. Ooh, easy one. The derivative of 2 to the x is going to be itself times the natural log of its base. Done. C. 22. An excellent problem. F of x is equal to e to the 3 ln of x squared. Now, this problem right here is going to be what separates the drones from the non-drones. If you are a drone, you're going to try to do e to the 3 ln of x squared and then chain out everything. Don't do that. Remember your properties of exponents. This is f of x equals e to the ln of x to the 6th. Now, notice how e and natural log have the exact same base. That means goodbye to you guys, which means you're really just dealing with f of x being x to the 6th, which is really 6x to the 5th, which is e. E. Cool. 23. F of x equals x rad 2x minus 3. Product rule. There is no way to avoid this one. So in this case, f prime is going to be first unchanged times derivative of the second plus the second unchanged, times the derivative of the first. Now, I think they actually simplify this out. So what you get is you get x over 2 rad 2x minus 3 plus 2x minus 3 underneath the radical sign, technically over 1. Common denominator here is going to be, oops, I'm sorry, wait a second. I totally forgot something here. I forgot to chain out a 2. So that 2 is going to cancel out here. So that means goodbye to you. So now I'm going to multiply by my common denominator. Bear in mind I am not rationalizing, I am just multiplying by a common denominator to get those two together. So what I've got is x plus 2x minus 3 all over rad 2x minus 3. The top becomes 3x minus 3 over rad 2x minus 3. That becomes A. I apologize for that mistake. Remember, I forgot to chain out the 2 right here from the 2x minus 3. Almost forgot chain rule. 24. Again, I'm going to write this in a way that will allow me to derive it better. They give you something different. I see x cubed plus x plus x to the negative 1. So now f prime is really going to be negative 3x squared plus 1 minus x to the negative 2. And now they want me to evaluate that somewhere. F prime at negative 1, that's going to be negative 3 times negative 1 squared plus 1 minus negative 1 squared. What I get here is negative 3 plus 1 minus 1. Goodbye to you guys. The answer is negative 3. That's not nice looking. 3, meaning D. Okay, in case you haven't noticed, 25 is just a repeat of number 8. So if you need to see 25, just rewind to number 8, and you'll see it. Okay, this one here. This one I actually kind of want to go into a little bit of detail over. f of x is equal to the natural log of x squared minus 1. Now, first thing I'm going to do, I'm just going to get rid of those absolute value bars. I'm going to take that for granted for a second, and then I'm going to show you why it's actually okay to do it in this particular function. F of x is equal to the natural log of x squared minus 1. And so that means that f prime is going to be 1 over x squared minus 1 times 2x. And the answer is D. Now, let's talk about that one for a second here. Why am I just able to arbitrarily get rid of those? Because if I look at this as a piecewise function, this x squared minus 1, what I really have is I have, let's see, on a number line, if I looked at x squared minus 1, between negative 1 and 1, I would be positive, then negative, and then positive, right, on x squared minus 1. Which means that on the sides where the function is positive, I would have x squared minus 1. Now, if I look at the middle, remember the middle on an absolute value is negative, which means I need to use the reverse of the function in order to maintain its positivity. So let's take a look at what this function looks like. If I derived this function, if I split it up into a piecewise, if I said, look, it's the natural log of x squared minus 1 when x is less than negative 1 and when x is greater than 1, and then I said it's also the natural log of 1 minus x squared when x is between negative 1 and 1. Let's see what happens if I derive both of those functions individually. Well, we already know what the top one is. The top one, because we already have the answer, is 2x over x squared minus 1. What happens if I derive the bottom, though? So if I derive the bottom one, I'm going to get 1 over 1 minus x squared times negative 2x. What I get is negative 2x over 1 minus x squared. Now, if I flip and factor out a negative 1 from the bottom, I get negative 2x over negative x squared minus 1, and guess what happens to those negatives? They say bye-bye, which means I have exactly the same thing on bottom as I do up top, which is why I could get rid of those absolute values from the start, meaning the answer is D. 27. No way around this one. You have to use quotient rule. So, the derivative is going to be low, D high, don't forget about chain rule, whoops, I went a little too crazy there on chain rule, minus high, D low, square the bottom, and away we go. So from here, there is nothing in the multiple choice that looks like this. So we have to figure out a way to simplify this. So I got 4x e to the 2x minus 2e to the 2x, all over 4x squared. So from here, what I can do is I can factor out a 2e to the 2x, 2e to the 2x, and that leaves me with a 2x minus 1 on the inside with a 4x squared. Well, that 2 and that 4 can go away, giving me with an e to the 2x times 2x minus 1 all over 2x squared, and that just so happens to be e. We are almost there, people. Hang with me. Number 28, more implicit differentiation. X squared plus xy equals 10, and they want me to find the derivative when x equals 2. Now, let me tell you, when x equals 2, y equals 3. I'm not going to show the work for that, but I'll tell you right now, I got y equals 3 by plugging x into here and into here. So I plugged x into x squared, and I plugged 2 into x squared and 2 in for x, solved for y, I got y equals 3. Let's use some implicit differentiation. 2x plus product rule here, first unchanged times derivative of the second, plus second unchanged times derivative of the first equals 0. Get dy dx by itself. You're going to find that dy dx is equal to negative 2x minus y over x. And now you just plug your pieces in. You're going to get negative 2 times 2 minus 3 all over 2. That is not a 2. That is a 2. And that is going to equal negative 7 halves, which is A. Okay, let's do number 29. 29 is going to take a little bit of explanation. They give you a couple of conditions. They say, let me go to that page real quick in the packet. They say that g of x is greater than 0. So that means that g of x is always positive. And they're saying that for all x. And then they're saying that f of 0 equals 1, which means that whatever you plug in, you're just going to get a 1. Oh, I'm sorry, if you plug in a 0, you get a 1. Sorry, I don't know what I was saying there. And now they're saying that h of x is equal to the two functions multiplied together. And that somehow, and before we even get to the second condition, let's think about what would happen if I asked you to derive this thing. If this was a free response question and I said, hey look, I just want you to find the derivative of h of x. You got two functions being multiplied, product rule should stand out. So you get first unchanged times the derivative of the second, plus the second unchanged times the derivative of the first. However, if you look at this problem here, in the problem, they're telling you that h of x only equals this portion, which means that, oops, I'm sorry, I didn't mark the derivative of the second. This is the derivative of the second. And so, when we look at h prime of x, they get rid of the second part, which means either g of x has to equal 0 or f prime of x has to equal 0. Now, they just established that g of x was always greater than 0, so there's no way g of x equals 0. That means that f prime of x had to equal 0. So when you derive f prime of x, you get nothing. Well, the only number in that choice that is a constant that is greater than 0 is e. So your answer is 1, or rather your answer is e. Kind of a cool problem. All right, moving on. 30. More quotient rule. F of x is equal to x squared minus 2 over x minus 1. Okay, more quotient rule. F prime of x is equal to low d high minus high d low square to the bottom, and away we go. Now, we are trying to find that for x equals 2. Here's what I'm going to do. I'm going to go ahead and simplify all this. I trust you will be able to do it. What I get is f prime of x is equal to x squared minus 2x plus 2 all over x minus 1 quantity squared. And again, I'm looking for that when x equals 2. You plug in 2's for everything. You get a 4 minus 4 plus 2 over 1, which is 2. Your answer ends up being D. 31. Scroll down a little bit. Simple problem. Y equals sine of e to the negative x. Lots of rules happening here. Y prime is going to equal cos e to the negative x. Now don't forget about your chain rule. The derivative of e to the negative x is e to the negative x, and don't forget about that negative 1. So what you really have here that looks like a multiple choice answer is negative e to the negative x cos e to the negative x, and that would equal e. We are on the home stretch, people. This is the last one. Y equals tan 2x, and they want us to just find the derivative at pi over 6. So the derivative is going to be secant squared of 2x times 2. Now, if I find out where y prime is true at what y prime is at pi over 6, I have to plug a pi over 6 into there. So what I get is y prime at pi over 6 is going to be secant squared of pi over 3 times 2. Now, where did the pi over 3 come from? If you multiply a 2 times pi over 6, the 2 and the 6 knock each other out. Secant of pi over 3 is 2. 2 squared is 4 times 2 is 8. In other words, your answer is, you guessed it, E. Okay, cool. Hopefully I didn't move too fast, and hopefully I am back in class instead of doing it on video. See ya.